Hi everyone, hope you all are good. So, we are here for grade 9 math. So, we are working on the book Principles of Mathematics Nelson, grade 9. We're going to start today with chapter 6, that is Investigating Relationships. The lessons we're going to cover today are 6.1 Interpreting Data, 6.2 Lines of the Best Fit, and 6.3 Curves of the Best Fit. So, let's just start with the first lesson. Okay, here it is Interpreting Data. Okay, here is the key idea. You can use a table of values to organize numerical data collected from an experiment. If the data points on the scatter plot seem to follow a perpendicular pattern, you might suggest that there is a relationship between the variables, right? Often the purpose of experiment is to determine whether the values of the dependent variable actually do dependent on the values of independent variable. So in some cases, either variable could be chosen as the independent variable, depending on your point of view. Let's just start with the practice questions. Okay, the scatter plot shows the ages of some tractors and their values. So you're going with a graph. The graph shows the age of a tractor and value of the tractor. Identify the independent variable and the dependent variable. Would you consider the variables to be discrete or continuous? Would you use a dashed line or solid line to join the points? Does the scatter plot suggest a relationship between the age of a tractor and its value, right? Okay, let's just look at the values of the age of tractor and values of the tractor. Okay, okay, the variables would be continuous, right? As both the age and the value do not change in discrete intervals. They are, you can see, they are changing in different intervals. Earlier it was just 2, then it is 3, then so that means it would use a solid line, right? The dependent variable would have to be value of a tractor. The value is the dependent variable and value depends on the age of a tractor, right? Okay, you can see the plot suggests a relationship between the age of a tractor and its value, as we can see a constant decreasing of value as the tractor gets older. So as the tractor gets older, the value is decreasing. So that means that is a relationship between the tractor and the value, right? Okay, let's just start with the next question. Let me see. Okay, we have so many. Okay, let's just start with question number 4. The data show the height of some grade 9 boys and their fathers. Identify the independent variable and dependent variable. Would you consider the variables to be discrete or continuous? Would you use a dashed line or solid line to join the pane? Construct a scatter plot for the data. Does the scatter? Okay, let's just look at A. Identify the independent and dependent variable. Okay, you're given the heights and you're given the height of the father. So that means the the height of the children would be independent, right? The height of grade 9 boys is dependent on the height of boys, right? You can see as the height of the child is decreasing, height of the child is the dependent variable on the height of the line, right? Okay, B is, would you consider the variables to be discrete and continuous? The variables are discrete, right? You can see because the values are not continuous, so that means the values are discrete. Okay, would you use a dashed line? Okay, that would be the dotted line, right? Because, okay, let's just start with question number D. Construct a scatter plot for the data. Okay, just plot the data on the graph. Then E is, does the scatter plot suggest a relationship between a boy's height and his father's height? Explain. Yes, that is a proportional relationship. You can see as the height of the father is increasing, the same way the height of the student is increasing, right? Okay, is there a relationship between the variables? Yes, they are related to the genetic factor, right? So, as the genetics of the father will influence the height of the father as well as the height of the son, right? Okay, let's just move on to next question. Okay, just look at the question number 6. No, let's just start with question number 7. The amount of fuel of a hybrid car uses is measured at various speeds as shown in the table below. Draw a scatter plot of the data. Describe any pattern you see. Describe the pattern you see in part B seem reasonable. Okay, let's just start with question number 7. Okay, let me read question again. Okay, the amount of fuel the amount of fuel a hybrid car uses is measured at various speeds as shown in the table below. Draw a scatter plot of the data. Okay, you are given the data, you have to plot a scatter plot. Okay, describe any pattern you see. Okay, let's just plot the scatter plot. Okay, you can use any online tool like Desmos or any, right? Okay, let me just plot this one on the Desmos, right? But it's a time taking process. I don't have that time. Okay, then you have to see, describe any pattern you see. Okay, let's just see, speed is 3, fuel is 14.9, speed is increasing, right? And the fuel consumption is decreasing, isn't it? You can see you have the value is decreasing, then again it is increasing. So that means a pattern of a sharp decrease in the beginning and then it is increasing, right? Okay, the C part is, does the pattern you described in part B seem reasonable? Yes, because when you start a car, when it has a low speed, it has a low fuel consumption, right? So as the car needs to use more fuel in order to accelerate from a stand still, right? Okay, then D is, does the pattern you describe in part B suggest how you should drive in order to minimize fuel consumption? If your speed is less between 40 and 67, right? You can see between 40 and 67, 3.1, 3.1, there's a constant speed, right? So if you want to minimize the fuel consumption, you have to be between 40 and 64, right? Okay, who would want this information? Why? The one who have the hybrid cars, I think. Are the variables discrete or continuous? The variables are continuous, right? As they change in infinitesimally small intervals, right? Okay, which variable does you choose for the independent variable? So which is independent? Speed is independent, right? And fuel is dependent on the speed. As far as you are increasing the speed, that means the petrol consumption is increasing, right? That means speed is independent variable and fuel consumption is dependent variable, right? Okay, let's just start with the next lesson, and the next lesson is lines of best fit. Okay, so let's just start with the lines of best fit. Okay, a line that describes the relationship between two variables in a scatter plot, that would be the line of best fit. So trend is a relationship between two variables for which the independent variable is time, right? If you have the independent variable that would be time, then that would be the trend. Okay, you can use a line of best fit to make predictions for values not actually recording or plotted, right? This is done by interpolating and extrapolating. Predictions can be made by reading values of a graph by using an equation of the line of best fit. Okay, let's just start with the practice questions. Okay, let's see question number 3. Okay, in this table x okay, in this table x represents the number of people enrolled in various classes at a health club, and y represents the number in each class that are male, right? So x is the number of people in various class health club, and y is the number of each class that are male, right? Construct a scatter plot. Okay, construct a scatter plot for the data, sketch a line of best fit, use the line of best fit to estimate the value of y when x equals 14, and use the line of best fit to estimate the value of y when x equals 27, right? Okay, let's just start with question number 3. So first of all, you have to plot these points, right? Then you have to make a line of best fit. Okay, let me just plot these points. They are 19, 10. Then because we have to see the graph. First, you have to plot all these points. Then for the second one, you have to sketch a line. Okay, for the third one, use the line of best fit to estimate the value of y when x equals 14. Okay, just look at the y when x equals 14. That means you have to use the graph, right? Okay, let me just make 19 then. Okay, the other points are 10 4 6 2, 10 4 6 2, 16 5 15 7 9 3, 16 5 15 7 9 3, 12 8 21 8, 12 8 and 21 8. Okay, let's just see. Here is the points, right? These are all the points we just plotted, right? Okay, now let me just read the question. You have to, when x equal, we have to look for the value of y when x equals 14. Okay, equals 14, right? 15 less than 15, you have 14, right? Just join them with a line and okay, that means the line connect the points there. They are 6 2 and 10 4, right? But I cannot plot a line, that's why I cannot see the values, right? Basically, the line goes through the point 6 2 and 10 4, so just use the point 6 2 and 10 4 to find the value of y. Okay, the points are 6 2 and 10 4, so just find the midpoint, that is y2 minus y1 divided by x2 minus x1. So 4 minus 2 is 2 and 4, that would be 1 over 2, right? That means it is 1 over 4, right? So just put the slope into the line and find the equation. So it would be 2 equals 1 over 2 times 6 plus b. It would be 2 equals 3 plus b, and 2 minus 3 is negative 1. b equals negative 1. Then the equation is y equals 1 over 2 x minus 1, right? That is the equation of line, right? Okay, let's just move on to next question. The next one is question number 5. A chair company has a contract to build all 1790 seats in a concert hall. Progress over the first week of work is shown in the table. Okay, estimate the number of seats built after 9 days. How many are built by the middle of 5 days? Okay, so first of all, you have to sketch a graph, right? Then you have to find the best line of best fit, right? So the line of best fit passes through the point 197 and 7 795, right? Just use these point and midpoint. It would be 698 over 6. That means it is 116.34. Now just you substitute the value of the slope in the coordinate to find the value of b. So it would be y equals mx plus b. Y is 97, m is 116.34 times 1 plus b. So it would be b equals 19.34, right? That means the equation is y equals 116.34 and plus minus it is minus 19.34, right? That is the equation. Okay, hold on, let me write down the equation again. Okay, the equation is y equals 116.34x minus 19.34, right? Okay, let's just substitute 9 instead of x, right? So it would be y equals 116.34 times 9 minus 19.34, right? So when you solve it is 107.64. That means the number of chairs produced in 9 days is 107, right? Now you have to calculate the value 1252 instead of y, right? So it would be 1252 equals 116.34 x minus 19.34. Just calculate the x, right? So it would be x equals 10.92. That means the worker can produce 1252 chairs in almost 11 days, right? Okay. So for all the questions, you just have to plot these points and make the best line of best fit, right? Okay, the next one is question number 8. Suppose that you plotted some data on scatter plot. How would you draw a line of best fit? Whenever you have to put a sketch a line of best fit, what would you do? You have to see the closest to all the points and keep an equal number of points on each side of it, right? I would sketch a line of best fit by drawing a line that's closest to all the points and keeps an equal number of points on each side of it, right? How would you determine an equation for the line of best fit? So we can find the coordinates of 2 points on the line and use them to find a slope. Then using the coordinates of a point, the slope, and the standard line equation, I would find the y-intercept of the line, like we did in the earlier question. We use 2 points on the we use two coordinates on the best fit. Then we find the slope, and then we have to use the slope to calculate the y-intercept, right? Okay, the third one is how would you use the line of best fit to interpret or interpolate or extrapolate, right? So I could use the line of equation and input either the independent or dependent variable in order to interpolate and extrapolate any estimates, right? Okay, let's just look at the next lesson, that is curves of best fit. Okay, let's see. Okay, you can see this is the curve of best fit, right? You can see half of the points are below and half of the points are above, right? Sometimes a curve represents a trend or pattern in a scatter plot better than a line, right? You can use a curve of best fit to extrapolate and interpolate values. Extending a curve involves more guesswork than extending a line, so you can't be as sure of your predictions. Okay, let's just start with the practice questions. Okay, weekly earnings from the movie Dude, Where's My Math book in the weeks following its opening are listed in the table, right? So plot the data on a scatter plot. So you have to plot these values and sketch a graph of best food. Which should you use solid, a curved, or a shaded line? Does it make sense to use as the curve of best fit to estimate the earnings after 3.5 weeks? Okay, let's just look at the value 9.2, 1 week, 2 week, 21.4. Okay, you can see as the weeks are increasing, right? But earnings are increasing and decreasing also, right? So sketch a graph of best fit. Should you use a solid? Okay, I am going to use the solid, right? Okay, the next one is C part is, does it make sense to use the curve of best fit to estimate the earnings after 3.5 week? 3.5 week. I think yes. Okay, does it make sense to use the curve of best fit to estimate the earning 20 weeks after opening? No, because the point 20 does not exist on the graph, right? So the correct option is no. Okay, let's just look at the question number 5. The ages and resting heart rates of some people are listed in the table. Plot the area, the data on a scatter plot, sketch a graph of best fit. Okay, these are the two very basic thing you have to do for every question. You just have to. Okay, you can see the heart rate is increasing 21, 24, 20, 60, 61, 63. The heart rate is increasing, right? Does it make sense to use the curve of best fit for interpolation? Explain. It is appropriate for interpolation as the points follow the curve and it makes sense to talk about the points that were not given, right? Okay, does it make sense to use the curve of best fit to estimate the resting heart rate for 85 years old person? Explain. No, the correct option is no. Okay, how do you know when to use a curve of best fit and when to use a line of best fit? Okay, you can complete the rest of the questions by yourself later today, right? Let me just see question number 12. Okay, how do you know when to use a curve of best fit and when to use a line of best fit? So we use a line of best fit when the point seems to follow a line and curve of best fit when the points seem to follow a curve. Like if they are making the curve, you have to use the curve of best fit. If their points are making the line, you have to use the line of best fit, right? Okay, how can you use a curve of best fit for interpolation or expoliation if you don't know the equation of the curve? So we can use the curve of best fit to extrapolate and interpolate without knowing its equation by sketching it and then using a graph to see where the value lies. Like you can use without equation, just plot the points on the graph and using a graph to see where the value lie, right? How do you know how far you can reasonably extrapolate? So as soon as the distance between the line point becomes so great that the curve can go in any direction, then the distance is so far for extrapolation, right? Okay. Okay, let's see question number 14. Dorothy has 20 meters of fencing to make a rectangular enclosure for her dog. Draw all possible rectangular inclusions when using whole number from 1 to 9 for the dimension. Organize the data in the table. Graph the relation area versus the length. What dimensions give the maximum area for a parameter 20? Write an equation. Okay, let's just start with the first one. Draw all possible rectangular closures using whole numbers from 1 to 9 to dimensions. Okay, you can calculate the parameter using 2 times length plus 2 times width because you are working on the rectangle. That would be parameter equals 2 length plus 2 width, and also when you calculate the area it would be length time width, right? Okay, the A part is draw all possible rectangular enclosures using whole numbers from 1 to 9. Okay, so okay, so you are given the parameter is 20, right? So it would be, let's just use this equation. Okay, P minus 2L equals 2W. Just divide them by 2, it would be P over 2 minus L equals W. So you are given the parameter 20. So it will be W equals 20 over 2 minus L. That means W equals 10 minus L, right? And you are given L 2 meters, so it would be 10 minus 2, right? That means 8 meter. So that means when the length is 2 meter and the parameter is 20 meter, the width is 8 meter. That is the width, right? Okay, you can use different values like 1 to 9, different values, right? Okay, for the B part, organize the data in the table. Okay, you have to make a table for length, width, and area. So here we did length is parameter, length is 2, width is 8, and the area is 2 times 8 is 16. So you have to use different values like this, right? Length is 1, width is 9, area is 9. Length is 3, width is 7. You have to make a total of 10, right? 7 times 3 is 21. So this is the different values you can use, right? Okay, the next one is graph the relation area versus length. Okay, then D part is what dimensions give the maximum area of the a parameter of 20 meter. So the point with the largest y value is the point where the area is 25 square meters, right? This means that for a parameter of 20 meters, the largest possible area is 25 meter square when the length and width are 5 and form a cube, right? Okay, then you have to write the equation. Equation is W. We have already did with the equation. W is equals P over 2 minus L. That is the equation. W equals P over 2 minus L, right? So we have already the value of P, that is 20. So it is W equals 10 minus L. And we know that A equals length time width. Put the value here, it would be L times 10 minus L. So that is the equation for the area, right? Okay, you can complete the lesson by yourself later today. So we are working on grade 9 math. We're working on chapter 6, that is investigating relationships. The lessons we have covered today are 6.1 interpreting data, 6.2 lines of best fit, and 6.3 that is curves of best fit, right? So please make sure before the next session you can complete all the test questions for the lessons we did today. So if you need more help with the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9, right? So that's all for today. If you have any question, you can please ask. Okay, that's all for today. See you in the next session. Bye, everyone.